I can start right now, right? Like, okay.
We're going to wait for
Oh,
see how
you
many people join us.
okay? Tell me when to go.
Sure.
Tell me when to start.
I'll give you an introduction and then hand it over to you.
Okay. We're also joined by two Delmhorst employees here. Uh, Rose Barros in our purchasing and customer service, and Valerie Garvin, who is in our accounts receivable, but also is learning product to handle customer service as well.
Great. Hi, Rose and Valerie.
You can't see them.
Yes, but I heard that. So we still don't have any participants that have joined us yet. So we're just
Oh,
we opened it
okay.
up and
It says 11 on
waiting.
my screen.
Oh, 11? Oh, I guess I'm not looking at the right thing.
Now 12.
Bryn,
Uh,
how do I see the participants?
I mean, minus one because I have two logins, but
Yeah, Ling, if you go to the participants at the bottom, it'll open a pop-up at the top of the
Got
page. You'll
it.
see
12.
two tabs,
Hmm.
one for panelists, one for attendees.
Yep. Thank you.
Morning, Matt.
Hi, everybody. Chris West, I see you there. Hi, Jacob. Hi to everybody. Some of you I don't know, but welcome.
now, Leland, will people be able to see me the way I have it right now during the presentation? Because that's
Yes.
Yeah.
fine. Yeah, okay.
So you
I
and I
mean,
are both sharing
okay.
our view, and I'll probably take my camera off when you're presenting,
Hmm.
but you can keep yours on and stay on their screen. So I
Great.
think yes, we're up to 14. We're almost full up, and just so you know, everybody that's attending, if you have any colleagues that you want to invite to join us, we we obviously have more room for everybody, and we really are happy to have you all be able to join this really timely presentation. So I'm Ling Young. I am with Efficiency Vermont. I'm a senior engineering consultant, and I've worked with many of you. Um, uh, I wanted to let you know that this presentation is being put on by the Efficiency Excellence Network, which is our trade network of our partners. And anybody on the call that is not part of our Efficiency Excellence Network, I encourage you to check out the network and consider joining. My colleague Bryn Oakleaf is going to put a link in the chat that you can follow to find out more about the Efficiency Excellence Network, which we also call the EEN, and to make it evident why you might want to join the EEN, I want to let you all know that Efficiency Vermont has rolled out a new benefit with the EEN, which is a loaner pool of moisture meters. So the moisture meters that Efficiency Vermont has are made by Delmorst, and that obviously is our presenter today is Ilene Cohn from Delmorst. And so we wanted to make sure that the moisture meters we have are out and getting used. So if you want to borrow, if you're in the EEN and you want to borrow a moisture meter, contact your Efficiency Vermont staff person that you work most closely with. It might be an engineering consultant, it might be somebody on our partnership team. Whoever it is that you work with at Efficiency Vermont, contact them and they will start the process for lending a moisture meter to you. And if you're not in the EEN, then join the EEN and then you can have access to that benefit as well. So I want to introduce our presenter. Ilene Cohn is the Manager of Technical Sales and Account Management at Delmhorst. She's been with Delmhorst a long time. Maybe she'll tell us how long. And she has been a great supporter and partner with Efficiency Vermont in helping us understand how to use moisture meters. So we're really happy that she was able to accommodate us on such short notice. We just set this up about 2 weeks ago. So Ilene, thank you very much for joining us. I'm going to hand it over to you now.
Okay, thank you, Ling, for that very nice introduction. I've actually been at Delmhorst next month will be 9 years. And I've enjoyed working here, always in a sales and technical capacity. Primarily Delmhorst manufactures moisture meters and only moisture meters along with thermohygrometers. There are larger corporations that, make moisture meters, but they make other things as well. Everything is made here at our Northwest New Jersey factory, and we service the equipment here as well. I hope I got your little logo correct. I stole it off your website.
Yeah, VEIC is our parent company.
Okay.
So Efficiency Vermont is part of VEIC. And I also meant to add that Ilene is going to pause a few times in the course of the presentation to allow questions. So if something occurs to you that you'd like to ask, feel free to put it in the chat and we'll bring it up when Ilene pauses for questions. Or if you want to ask your question live, when she pauses for questions, we can unmute you and you can speak your question to the group. So keep the questions coming.
Great, thank you. And that helps me knowing that people are actually listening and want to talk instead of, as I mentioned to Ling and Bryn before, me talking into a black hole that, I can't see anybody. So, and as you ask questions, I will note down who asked a great question and I'll have some Delmorst swag sent to Ling later today to hand out to, or to send to those that ask great questions. Okay, why isn't this moving? Okay, so title of the discussion is Understanding Moisture Meters for Optimum Results. Not to read here, but why do we use meters? How do you use them? How to test building materials and how to correct for some factors that affect your readings. And then how to care for the equipment, which is important because although we have warranties on our equipment, it's not cheap to repair. And so you want to take care of it as best as possible. We've been in business since 1946 here at Delmorst. We were founded by Mr. Bill Delmorst, and his right-hand man, Aristide Lorenzi, took over the business. And now we're in the second generation of the Lorenzi family running the business. And again, everything is done here, including manufacturing and repairs and service. We service several industries, and I'm going to only talk about the industries that relate to what Efficiency Vermont does, meaning around the building trades and home inspection and flooring. But we also make moisture meters for agriculture, primarily is our secondary or second largest business, I should say, as well as paper, which I'll review a little bit. I don't know if you're seeing the full screen or if I'm not seeing it. Do you see the top line of my screen where it says, why should I use? Because I think do you see that link?
We see it.
Yes, yes.
Because I don't see the top line, but I do see it on the bigger screen here. So, okay. I think the Zoom app is covering part of it. So that's fine. So why do we use moisture meters in building and home inspection and indoor air quality? We want to trace leaks. We want to find exterior moisture. As you can see here, some testing being done. Check moisture in various building materials, which our meters can do. Also check the ambient air, because that affects how your building reacts to its environment, relative humidity, temperature, and some other factors as well. As most of you probably know, moisture intrusion is the single most important factor affecting the integrity of buildings. In water damage restoration, when moisture goes unchecked, you have a similar problem. You have, we service areas that are hit with hurricanes, tornadoes, major flooding from rains, and just, your regular everyday plumbing leak. So the moisture meters can assess the damage. They can ensure the structure is being dried. It's easier to bring in. And if can you all see me, Ling? You can see me, right? Ling, you can see me, right? You guys?
We
Yes.
can.
Okay.
Moisture meter you're holding up is a little
fuzzy.
There you
So,
go. There you go.
What I
Right
was
there.
going to
That's
say
perfect.
is, okay, it's easier to bring in a little lightweight moisture meter, a little handheld moisture meter, and just check before you remove all this heavy equipment that you're seeing here. Before you remove it, check that you've dried everything with your fans and your dehues and your air movers and make sure everything's dry. And then pull it out after you've checked. In flooring, and woodworking, not so much your business, but flooring for sure. Flooring installers, people who are inspecting flooring for moisture, have issues with either too little moisture. You have these issues here, primarily cupping and crowning in the floor, but too little moisture also causes issues. We were at the NWFA, the National Wood Flooring Association trade show in Milwaukee in the spring, and also at a wood furnishing show in the summer, this summer. And I've got people coming up to me because we were in Arizona or Nevada. People from that area in the desert Southwest think that because it's so dry there, they're not going to have issues with moisture. But in reality, they do, and they're not realizing why, because it's too dry and too little moisture does cause problems as well. The flooring industry has, most flooring distributors and resellers and installers have an insurance office in their own location, because there are about $1 billion worth of flooring claims annually because of faulty installation or inspection issues. So it's a big business, for lawyers and litigation in the flooring industry, particularly when it comes to wood flooring and wood subfloors. They're just not following the correct installation procedures. So how do moisture meters work? We have 2 meter technologies essentially for moisture meters. Not talking about thermohygrometers right now, just moisture meters. We have pin meters, which work via resistance technology, meaning 2 points of contact into the material and measuring the actual resistance in ohms, and our firmware in the meters change that over to moisture content percent or a moisture content reading. And we have pinless meters, which work via capacitance technology, sending a signal down into the material to measure the moisture. So both can operate in different building materials. Essentially, you can measure moisture in any material that has hygroscopic properties. Hygroscopic meaning the material can take on or give off moisture. So styrofoam, you can't measure moisture. It doesn't take on and give off moisture. Most glass, you can't measure moisture in most glass. It doesn't take on and give off moisture. But you can in wood, in drywall, in concrete, and plaster, stucco, and all kinds of building materials that are generally used, even paper, which we'll go through later. Now, what moisture meter do we choose? You guys are using our, if I can hold this closer, our Navigator Pro moisture meter, which is a 3-in-1, which we'll review a little later. And you use our pinless meter, the Pro Scan. I'm trying to hold it so you can see it. The Pro Scan is a pinless, standalone pinless meter where there are no pins. So how do you choose? Well, essentially, there are 3 questions to start with. Then you can get into the meat of the material, but there are 3 questions to start with. And the first one is, what are you testing? Most meters contain calibrations for wood. Some have drywall, very few. We have meters that test hay, paper, etc., which will give you a true moisture content percent, a quantitative number, unit of measure on the material. Or you can use a meter with a relative scale to establish a dry standard. Your Navigator Pro has some materials in there on the pin mode, and I say pin mode, you can attach a pin electrode to this connector. But on the pin mode, you have some materials that don't have a real quantitative moisture content scale, and some that do. Concrete, stucco, plaster. Those are not materials that all have a true moisture content quantitative number to read. And we'll talk about how do you handle that. As well as your pinless mode in the back, that is a 0 to 300 relative scale. Again, what you need to do is establish a dry standard comparing wet to dry. And we can talk about that. So what's a dry standard? In the water damage restoration industry, they use a dry standard in those instances where you don't have a scale. to give you a true moisture content percent. So how do you do that? So say I'm testing plaster today, and there was a problem with the plaster in a building, and I don't know what number is good on plaster. What's a good moisture content percent on plaster? Well, if you take an affected area versus an unaffected area of the plaster, if you have that opportunity, that's the best way to establish a dry standard. You take a reading on an area of the material that was unaffected, that you know is dry, and establish a number. Let's just say on a 0 to 300 scale, let's just say the dry number is 50. Good dry plaster in your building on the plaster that you have there, because there are many different plaster compounds, is 50. So now you know you need to be at 50. Now you go to test your other plaster where it was affected by moisture, and you get 80 or 100. Well, if 50 was dry on that relative scale, 80 or 100 is not dry, and you have to dry it down to 50 and use drying techniques to dry it down. And that's what a dry standard is. You're establishing a dry standard on known dry material of the same substance that you're testing as to whether it is dry or not. Ling, I'll open it up to questions on that. I know that's a controversial subject that everybody always asks questions about.
Are you opening it up to questions right now?
Yeah, if anybody has any questions about dry standard versus moisture content percent.
Okay, well, I have a question for you. So
Yeah.
just to be clear about that, you only would need to use a dry standard for a material that doesn't have
A calibrated scale.
Yeah, okay. So maybe you could say a little bit about, like, give us an example of a material that does have a calibrated scale.
Sure.
And I think that maybe my guess is many people on the call are thinking about wood and drywall. And so where does that fall in the whole dry standard versus calibrated scale?
So wood was the first material in building structures that Mr. Delmorst tested. Mr. Delmorst came into business by inventing meters to test wood for mostly buildings in New York City. New York City had a problem with moisture, and he was from here apparently, but he went into New York and received contracts from the city to test moisture in wood and building materials. And so most moisture meter technology was originally based on wood calibrations and then taken from there and extrapolated from there. And now we have, in our labs here, we have ovens and chambers to test other materials. So you're lucky you have a Delmorst meter, and I'm biased, but we're one of the very few companies that have a drywall scale, a true drywall scale. And I have a lot of charts and graphs about the drywall scale versus a wood scale later on. So wood and drywall will offer you a true moisture content percent on the meters. So you don't have to worry about that, but you do have something else to worry about because other people don't understand how that works, but you will after we're done.
And are there any other questions about the dry standard from the attendees?
If folks want to put those in the chat or raise your hand, we can pull you off mute. Great. I think we can keep going, Ilene. Thank you.
Okay, great. So again, what to ask yourself, how do you pick a meter? So the first question is always, what are you measuring? So different meters have different material calibrations in them, or the or the relative scale, as we just discussed. The second question is, what are the dimensions of those materials? And how hard are they? So is it some big tree trunk? Is it a small piece of a 2x4 piece of lumber? Is it a piece of drywall in a building? That would determine what electrode attachments you choose. So most of our pin meters have, as you see here, a connector or pins on top of the meter, as this one does. If you see the pins here, to penetrate the material and obtain a reading. So what type of electrode are you going to use? Ones with long pins, short pins, We have blade electrodes, and I'll show you those. I'll have photos of those in a little while. And then the next question is, and that's a question to ask yourselves because you use meters that have pinless options as well. So do you use a pin meter to penetrate the material, or are you using a pinless meter? Are you walking into somebody's home with a $200,000 exotic wood floor and you're not sure if there's moisture? So you don't want to start poking holes in it with a pin meter or some big electrode that we have that's called a slide hammer with pins. You possibly want to first go in with your pinless meter and not do any damage and just check quickly where you may have moisture problems on their $200,000 floor made of exotic woods. And so that's a choice to make, pin or pinless. Also, how big is the area that you need to test? It takes a little longer to make pinholes and test with the pins, but pins give you greater accuracy. So we'll go through that as well. So those are the three basic questions to ask in terms of selecting a meter. When you're choosing a pin meter, again, you're going to choose that electrode as we talked about. We have behind the wall probes. We have slide hammers for hardwood flooring on the pin side. And on a pinless meter, you need to consider the depth of the reading. In other words, how thick is that material that you need the meter to read down to? Your pinless meter that you have, our ProScan, which is our top pinless meter, that can read between 3/4 of an inch to 1.25 inches down into the material. Well, if the material is 5 inches, you're not getting all the way down. Then you're going to need another tool. Now, how do you know if it's reading only 3/4 of an inch or is it reading down to 1.25 inches? You don't. It's giving you an average. When you're using a pinless meter, you're getting an average of readings, and we'll go through that as well. So the depth of the readings, and also if it's a thin layer, let's just say you have some sort of veneer. Veneers or engineered woods are much thinner than a hardwood. The pinless meter is going to read whatever is below that veneer or engineered wood, especially, of course, if it's hygroscopic. If that material below your wood can take on and give off moisture, then the pinless meter is also going to read that. And that's going to be incorporated into that average on your readings. So you want to take that into consideration. You don't do this, but people who are installing veneer or installing hardwood floor will test the boards first, or the pieces of veneer, with a piece of, let's just pretend this is foam, a piece of styrofoam underneath, a styrofoam board underneath, because the styrofoam board will block any further readings from going through. So if the piece of veneer is on top, they can put the moisture meter down, let's say this is a table, down on the wood with styrofoam below, and it will only read the wood because that's all it can see. It can only see hygroscopic materials that take on and give off moisture. So that's a consideration when you're talking about a pinless meter. Here's a great example of how pin and pinless meters work, as I kind of described. With a pin meter, your readings are not affected by the sample size. You just need the right proper length of pin. And you're going to get specific readings, especially with insulated pins. You won't get a reading along the shaft. And Val and Rose hear me say this all the time. You'll only get a reading at the depth at which you place the tips of the pins. So you can go down 1/8 of an inch, 1/4 of an inch, 1/2 an inch, and keep hammering down and taking readings along the way and obtain readings at various depths into the material. So here it might be 8%, as you see here on the graphic, might be 10% down below, 11%. You might have a wet pocket that's way too high and it's going to cause problems. And so you need to dry that out or figure out what you need to do with that material. A pinless meter, on the other hand, you can test large areas quickly because you don't have to hammer it in pins. So you can put it down, pick it up, take a reading, pick it up, put it down, don't slide it. You ruin the back plate. But just test a lot of area quickly and take readings The board just needs to be wider than this plate on the back of the meter, as you see there. You need to cover the whole plate with the material. Sorry. Again, know that limit. Know that you're only going to go down as deep as 1.25 inches. You can set the meter, as you may have done in your ProScan manual, for specific gravity of the species. We have in the back of the manual the specific gravity or density of the wood. Again, all of these things for which you can preset the meter afford you greater accuracy in your readings. So if I know I'm testing white oak, I'm going to set the meter for white oak. I'm going to hit species and I'm going to go to 0.46 because I know 0.46 I believe is white oak or Doug fir. I'm going to hit the on again, and now I have, it says low because there's nothing behind it, but if I put my hand there, human is too high. I'm setting the meter for the species of wood I'm testing, if you know the species of wood. If you don't know it, put it on 0.46, that's a default, and test that way. But that specific gravity reading that you see in the back of the manual for the ProScan gives you greater accuracy based on the specific gravity of the species that you're testing. So the problem here is with a pinless meter, you don't know what the reading is down here. You don't know if it's 8% or 10% as you would with a pin meter with insulated pins. You're getting an average from the surface on down to the depth at which it can read. Again, good for testing large areas quickly and just determining where there might be moisture, and then going in with a pin meter if there is a moisture issue.
Ilene, I have a question.
Yeah, sure.
So you said that the material that you're measuring with the pinless meter, the ProScan, needs to be wider than the scanner.
Yeah, the board, you see this
How
panel?
wide?
You can see
Yeah,
it
how
there.
wide is that? That looks about 3 inches or
Yeah, the whole meter is
inches?
about 4 by 2, 4 by 3. The back panel is about 2 by 3, I would say.
okay.
Yeah,
So I'm thinking about framing. So this is not something that you could put on the edge of a 2x and get a read that way.
correct. The other issue, and we'll review that too, is the smoother the surface, the better. So you have to cover the whole back plate, and the smoother the surface, the more accurate your reading will be. So finished floors, you know, concrete, if it's not as smooth, you know, there is smooth concrete. You know, you go to a Walmart, it's nice and smooth, it's polished. But if you have raw concrete and it's, you know, not as smooth of a surface, you won't get as accurate a reading because the material has to come into contact with the plate on the back of the meter. So in those instances, Ling, a pin meter might be the better choice. Okay, but we have some other options as well, which may help, and I'll go through those. So what factors affect your reading, which kind of brings up what Ling was just saying. With pin type meters, of course, moisture content affects any reading. The ambient conditions are going to affect your reading on a pin meter. The relative humidity and temperature, or the EMC, as you see there. Sorry, the meter just went off as a battery saver. Equilibrium moisture content, which is a combination of the temperature and the relative humidity, and where your material equalizes with its environment. And of course, the material or species of the wood or the type of material you're testing affects the moisture reading. That's why you set the meter for it, because different materials have different electrical characteristics. And again, the meters work via electrical resistance or capacitance for a pinless meter. Other factors that affect the reading are the pin type and the grain of the wood. Here's an example of how the ambient conditions will affect your reading. For those of you that were in my session 3 or 4 years ago, I showed this map. It's always a great map to show in terms of the different areas of the country and how the readings are different. So wood, and we're relating this to wood because again, that technology began with wood in terms of moisture testing. Wood reacts differently in different parts of the US. We'll take the US as an example because we know that the best. In the coast of California and the Gulf states around the Gulf of Mexico, you have a higher relative humidity, and in most cases a higher temperature. So wood is going to equalize at 11%, and that's an average year round. So people in those areas use 11% as a good number for testing wood moisture content. As opposed to people in the desert Southwest where it's very dry, wood equalizes, again, a year-round number at 6%. And that's because the relative humidity is so low compared to these other locations, Gulf Coast and the coast of California, where relative humidity is in the high 50s, low 60s. Most of the country, year-round relative humidity is 40 to 45, and wood's going to equalize at 8% moisture content. So that's something to take into consideration when you're doing your readings, particularly if you're not in an HVAC controlled environment. If you're taking readings outside, or if the HVAC in a structure was off for some reason, an electrical issue, and things weren't working, and it's real hot in the building, and either very moist or very dry. It's a good graphic to show on this chart how relative humidity and temperature affect the equalization of wood. Again, just as that map showed, at 70 degrees Fahrenheit in a 30% low humidity environment, down here is the relative humidity, wood's going to equalize around 6%. In a 45% relative humidity environment, we have that 8.5% wood equalization, or equilibrium moisture content. And at 11%, at 60% relative humidity, high humidity areas, all at the same temperature, that's 70 degrees, wood is going to equalize at 11%. So that's the goal for people measuring wood in those high relative humidity areas. And this chart was developed by the U.S. Department of Agriculture and also used by the National Wood Flooring Association and Wood Furnishing Society.
Ilene, is this
Yes.
chart in the manual with the two meters that we have?
It is not, but I'd be happy to send it to you.
Okay, I think we will tuck it into the case with those loaner.
Sure. Yeah, because you have people across the country, right? Working.
No, just in Efficiency Vermont.
Okay.
I mean, just in Vermont. We're working with people in Vermont. So also, I think anybody who attends and would like this chart, and you're not borrowing our meters, you just want to have the chart, just contact us and we will forward what Ilene sends us.
Sure. Yeah, I'll send everything to you, Ling, and you can disseminate that information.
Yeah, and just to be clear about what you're showing on the chart, what I'm gathering is you're saying if you're in the environment shown here, so for instance, it's 60% relative humidity, the temperature in the building is 70% or 70 degrees.
70 degrees. Yep.
When you measure wood, if it's higher than 11%, then that is wood that is higher than it would be under natural conditions. So it suggests that it's gotten wet. The wood has gotten wet. So these numbers that are shown in the chart here are thresholds that you would use to say like, oh, this material is wet or it's okay.
Correct.
And it depends on what the relative humidity is and the temperature in the building.
That's right. Now, as you can see, with higher temperatures, you'll have a different reading. The reading will go down slightly in terms of the moisture content. You see that, say at 90 degrees, you have lower moisture. These numbers all on the chart are moisture content percent numbers. Even at the same relative humidity and a higher temperature, you're going to get a lower moisture content reading. And conversely, at lower temperatures, you'll get a higher reading. So these are this is again, the Forest Product Laboratory in the U.S. Department of Agriculture. These were tests done by them. And this is not a Delmorst chart. This is from them. You know, I see this chart all over the place that people use this in their presentations. Any other questions on this? Okay, I will get that out to Ling. Okay, so what else affects pin meters? Temperature. The single most, and again, it relates to the chart we just saw, but the single most issue that affects the readings on moisture meters is temperature. And of course, the great thing about the meters that you have, and we're not talking about pinless meters, we're only talking about pins, so not the ProScan, not this guy, but your Navigator Pro has temperature corrections internally. So if you had an analog meter, which we do sell, some people like to see the needle go up the scale, but if you had one of those, all of these corrections have to be made after you obtain the moisture content. You have to correct for all those things later on. But since you have digital meters that allow you to preset the temperature, the material, and some other things that we'll talk about, the reading on the screen after you make those presets before you start testing, the reading on the screen is your actual moisture content reading. So with temperature, as the temperature increases, as we just saw, electrical resistance decreases. So your indicated moisture content on the screen is going to be higher, and you need to correct for that. Again, by putting in the temperature of the meter's doing that for you. So you can either test the ambient temperature with your thermohygrometer, which you have on this meter, as well as a pin meter and a pinless. But you can use your thermohygrometer to test the temperature and the relative humidity. To test your material, if the material was just moved into an environment and it hasn't acclimated to its environment, you can use an infrared thermometer to test the temperature of the material. We don't make those, at least not yet, but other companies do. So if you have an infrared thermometer and you need to test the material temperature, that's the optimal thing to do. But you can test the material, you can test the ambient temperature if the material has been in the environment for a few days. So you have a built-in correction. We also have manual corrections, again, for people who don't have our more advanced meters. So you adjust for the varying material temperature. The default temperature on all our meters is 70 degrees. It's useful primarily in environments that are extremes. We say extreme. Above 90, that seems to be common this summer, or below 50. If you're within that range, between 50 and 90, the effect on the moisture content isn't that great. It's only a point or so. But when you get above 90 and below 50, I've seen differences in 10 points moisture content. That's huge. And so you do need to make those temperature corrections if you're primarily in extreme temperatures. Take the temperature reading every day so you know the environment you're in. This is good for wood materials primarily. The other materials don't react as much to the temperature as wood does. There's a great graphic, and I can send this to you also, Ling, to show you how temperature affects wood. Lumber stored outside in Vermont in a lumber yard, or in a home in January in Vermont that lost its HVAC system. It's 20 degrees in the house. You're testing the wood because there was some water damage as well. You're going to read 25% moisture content on the screen. Again, not on your meter. This is if you're using an analog meter. I'm showing you what your Navigator Pro is doing behind the scenes. So if you set the meter to 20 degrees, the true reading that comes up is 34% moisture content. So those analog meter guys are going to get 25 on their screen, and they have to correct for it after they take the reading. They have to see what the chart says at 20 degrees. Oh my screen says 25, my analog meter says 25, but the real moisture content for this wood, because I'm in this temperature, is 34, a 9-point swing, very large. Conversely, if I'm in where is it real hot? Texas. And I'm testing wood this summer that is in the environment without air conditioning. That same 25 on the meter needs to be corrected down to 19. So as the temperature rises, the indicated moisture content rises at 120, it rises, and you have to correct it down to 19. Again, you don't have to do anything except set the temperature in your meter. Then all of this is done for you. We're just here showing you what the effective temperature does to the moisture readings. And you're lucky you have a meter that can correct for that before you even start taking the readings. You don't have to start looking at charts and graphs after the fact. So what else affects moisture readings? The material. In this case, we're looking at wood species corrections. This is just a subset of hundreds of different wood species that we have in our internal files here at Delmorst. You know, there are exotic species from other lands. There are species indigenous to North America, and which is primarily what you see some of here. So the top line meter reading is a default Douglas fir. That's the default wood species on most wood meters. And so, again, if you cannot set the material on your meter, you have to look at a chart. But you can set the material on your meter. We're just showing you what the meter does behind the scenes. If I get a reading of 16, but I'm testing American elm today, that 16 is really 13. Again, you set your meter to American elm, or a correction that you call me about if you know what you're testing. Again, I know when you're doing building inspection, most of the time you don't know what the wood species is, unless you're a wood expert. Some people can visually say this is American elm or this is white oak. So you're just going to generally go by Doug fir if you don't know the wood species. It's always great to know it, and you can preset the meter accordingly. And this is what it does. So here's a 3-point difference. In a lot of cases, it's not that wide of a swing. It could be 3 or 4 points difference, but 3 points could make or break the situation in terms of moisture. So your meter, again, does that behind the scenes if you set the species accordingly. Now, the Navigator Pro doesn't have a lot of species. It's more for a building inspector or water damage restoration contractor. So it has a handful of species in there. We have wood meters that have up to 200 wood species corrections internally in the meter. In one like this, for example. But if you want to just stick with the Doug fir reading as a default, know that it could be plus or minus a few points. Again, not as significant as that temperature issue, but still could be 2 or 3 points. Any questions on that?
Ilene, what the other one, ScanPro, how many wood species are programmable in that?
So the pinless meter, the ProScan, actually provides you with about 70 different wood species, but you're not selecting the name of the species. You're selecting, as I mentioned, the specific gravity or density. So with that, let's just say you know you're testing white oak today, or Doug fir, or whatever have you. You're inputting a number. I don't know if you can see the number there. You're inputting a number. It's a decimal point number. It's a decimal number. And that number, how do you know what to put in there? The number is in the manual that comes with the ProScan. The last 2 pages give you about 65 or 70 species and the specific gravity decimal number to plug into the meter. And then that will be a preset for the wood material on the ProScan. Good question. Ling gets swag.
Keep those questions coming, folks. We don't know what Ilene's going to come up with. I think it's going to be better than a hat.
Okay.
Are there any other questions? Chris, I do see your question, and we're going to hold that one to the end if you feel like you haven't had it answered. But is there anything else about setting the the species of the wood and how that and the temperature and how that affects the readings.
And just to let you know, anytime while people are thinking, if you have a species that's not in your Navigator Pro, or we can do this for pin meters, you can call our office, particularly myself or Jessica, who's not in the room. You can call our office. If you have some exotic species or some species that's just not in the Navigator Pro, because again, it's not for a wood flooring guy necessarily, it's not for an installer. Those are the wood meters. We have pure wood meters that have hundreds of species in them. We'll give you a correction to set your Navigator Pro for. We'll tell you what to do if you're not sure. So feel free to call me anytime. My number will be at the end. And you can contact me. I'm here all day, most days. Okay. Were there any other questions, Ling, at this point?
Not yet. There's
Okay, good.
not a lot of competition for the swag.
Not a problem. So how do we use the pin mode? The pin mode gives you more precise readings, again, because you have, especially when you're using insulated pins at specific depths, you get moisture readings from the surface on down at particular depths. Always insert, as you see in this photo here, insert the pins parallel to the grain. So you see these two pins here are going the same way the wood grain is going. That gives you greater accuracy. Just the way the meters are programmed. And this is a slide hammer that's used for hardwood flooring, and you can hammer down. You see the person holding the middle there. They would put the other hand on the top and hammer it down and then press the button on a meter and take a reading. Again, always understand in a pin mode or pinless that in some cases you're testing moisture content as a quantitative number, a real percent, and in some cases that dry standard, a qualitative, comparing wet to dry, a qualitative number. So Ling and I spoke a couple of days ago about, or emailed about, what we should cover. I'm going to go through this real quick. A lot of you have used the ProScan and the Nav Pro. I'll go through some screens very quickly. And anytime you have somebody using the meter and want to call on the job, feel free to call. I'm here from 8 to 4:30 in the office. So there's a pinless meter. Why do you use a pinless meter? Again, scan large areas quickly. It can be used on its own or in conjunction with a pin meter once you find areas of concern. They're non-destructive, as I mentioned. You don't make holes in things and destroy them. Sorry. All your meters that you use currently have built-in calibration checks. Not only do you have the species or specific gravity settings for about 70 species, but you also have a 0 to 100 reference scale. Again, that qualitative scale, not the quantitative. You have both. You have a qualitative scale, 0 to 100 on that pinless meter, comparing dry to wet on the same material. Oh, there you go. So you can go between 3/4 of an inch, actually minimum down to 1.25 inches without damaging the material. Some key functions here, as I showed you, you can set the specific gravity or go up to the relative reading. All you're going to do is press the up button all the way and you'll go to, I don't know if you can see it here, you can go to the reference scale. If I press this, let's see if I can get a clear picture here. You see what it says ref, REF? That's the reference scale. If I press the up or down arrow all the way and let it go all the way, it will go to the reference scale, and that's your qualitative scale. The meter will allow you to check the calibration. So before you start work on any meter every day, check the calibration. You're not recalibrating the meter, you're just checking that it's in calibration. And there's a key to do that on the meter. And you can check that the battery is good to go as well. It'll tell you battery passes. If there's ever a problem with the meter, you call us. We have a form on our website. Call us or use the form and return the meter with the form. The address is on the form as well. If the meter is in warranty, which these two meters that you use have a 1-year warranty from date of purchase, or date of when you received it. We will repair them at no charge, in terms of the warranty being against materials and workmanship. If you ran over it with your truck, we'll probably have to charge it. Basic alarm setting. You can set the alarm as a threshold. Let's just say, as we looked at that ambient relative humidity and temperature, you know that you can't be higher than, if you're in Vermont, 8 or maybe even 10%. If your wood is higher than 10%, that's a problem. So maybe you want to set the meter at 10 or 11% as a warning, and it will beep when it hits that threshold that you set on your own meter to warn you that you're above the limit that you set the meter for. Again, cover the back scan area, the back panel of the meter with the material. It's got to be fully covered. Don't slide the meter along the material. You'll scratch that back panel. Better to just put the meter down on the material, take a reading, pick it up, put it down somewhere else, take a reading. But again, you can do that more quickly than a pin meter, and that's the advantage. There is a hold key to hold the reading if you're in the dark or in an area you can't see it. Then you take it out and then you can see it because you've held it. Use those ProScan meters to make sure the integrity of the building is sound. Use the specific gravity scale or the reference scale. We mentioned smooth surface conditions are best. These are things that affect the meter reading. Surface moisture will elevate the reading. Something to be very careful about, hidden material. If there is any metal below the flooring or below the surface of the material that you're reading, whether it's wood or something else, drywall, concrete, any metal will artificially elevate the reading. Why? Because these work via electrical properties, and obviously metal is a conductor. So it's going to elevate the readings artificially. So take that into consideration. And if you think you have metal underneath there that is elevating the reading, that's where you would go in with your pin meter, because you can move it over and avoid that spot. Okay, your NAPRO. Some of you have these. I know that you've bought a number of these as well. The NAPRO is a great meter because it's a 3-in-1 meter. What does it have? It has a pin mode, a pinless mode, and a thermohygrometer. That's that black sensor here. That's detachable. You have a basic mode where you can just take readings. If you want to take a picture of the screen, you can do that. It has a backlight. You can set a backlight for it. And it has an enhanced mode. What does enhanced mode do? Enhanced mode allows you to store the readings. And you can look them up later. You can even download them to a Windows computer via an Excel spreadsheet. So you can download the readings. Whoops, sorry. So there are your 3 parts: the thermohygrometer, the pin electrode connector, and the back is a scan mode. So you can take the readings in basic mode. You have these 3 scales in pin mode, and you have some different wood materials in there to choose from. You have a drywall scale. There is somebody else that copied our drywall scale, so I can't actually use the word exclusive anymore. They did copycat, but we invented the drywall scale. We tested it here. We tested various drywall materials here and including gypsum, which is what drywall is primarily made of. And you have that scan mode on the back of the meter. That's a 0 to 300 reference scale. In your enhanced operation, you can set up jobs and rooms. You can set up commercial jobs or residential jobs. We have names of rooms for each. And you can store up to 2,400 readings and view them in the meter or download them, as I mentioned. The thermohygrometer will measure all of these functions: temperature, RH, dew point, and grains per pound. So you'll have all those readings. Grains per pound and dew point, I don't know if you guys use that as much. It's used in the water damage restoration industry as well. The thermohygrometer acts very quickly. I'll give you an example. We're in our conference room. I'm going to put the meter on RH mode. I just set it for RH mode. See if I can get this. And I'm gonna press the button. And the meter came up very quickly. It's acclimating. 53.3% relative humidity, and the temperature in here, I knew it was a little warm. It's 74 degrees. I'm looking at Rose. Rose and Valerie are always warm. So acts very quickly. These are some slides of what the screen looks like for a residential job or a commercial job. You can set up either. It'll show you the temperature when you do your reporting. You can highlight the up and down arrows and change the rooms. Living room, as you can see here, dining room, kitchen. Not sure what E is. Maybe entry. Bathroom 1, bathroom 2, etc. You can set up and define up to 32 rooms, and then within each room, you can set up a wall, floor, or ceiling designation and test each accordingly, and it will save it in those sections. You can do the same thing with your scan reading. Set up the scan mode. And then you can insert the thermal hygrometer and take your RH and temperature readings and other ambient air readings as well. If you go up and if you work into Canada, I don't know if you do, Ling, but there's a centigrade option, Celsius option on the meter as well. Oops, sorry. So these are the pieces of equipment that come with the kit. You have an infrared base module on the left, that yellow box. You have an infrared link on the side of the meter. I don't know if you can see that, but right here, as the picture is showing you. And once you put that next to the box and put it in the download mode, and you attach the box to your PC, you can download the readings that you took. And it will look like this. The initial download will look like this, but it is an Excel spreadsheet. And then you can put your own letterhead on top of it, put the technician's name, date, so forth. But you already have the date and time of each reading. So that's what it'll look like. And then you can, again, save it to an Excel spreadsheet and change it around how you wish. So that's the Pro Scan and the Navigator Pro. Quickly talk about, are we at a hard stop at 9:30, Ling?
No, we're not. We can keep going.
Okay. A few more slides. Some useful features in meters that you have, mostly. Interpretation of meter scales, as we discussed. Not all scales display moisture content. What are you using? Wood gives you a true moisture content in all of our wood meters, or meters that have a wood scale. Usually 6 to 40%, some have 6 to 30%. Keep in mind, when wood is over 30%, and when you're testing wood in it, even though the meter can read over 30%, when wood tests over 30%, it's actually beyond what we call its FSP, fiber saturation point, meaning it's at a point where most wood species can no longer take on or give off moisture. So above 30%, those moisture content percent readings are really what we call relative, because it can't do anymore. The cells of the wood are filled and the water's free flowing. It's beyond this fiber saturation point. So below 30, you're going to get more accurate readings. This is an example of our analog scale, again, where everything's Doug fir, 70 degrees, and you have to manually make those corrections, unlike the meters that Efficiency Vermont has, where you can make those corrections, as we said, before you take a reading. But if you have a reference scale, know that they're comparative readings. We have different reference scales. We have a 0 to 100. We first came out with that. But unfortunately, people took that 0 to 100 reference scale and they put a percent to it in their mind because, oh, it's 0 to 100. That must be a percent. So we tried to trick them and make a 0 to 300 reference scale. But then they would just do the math and try to equate it to a percent. So either way, know that when you're in a reference or relative scale, it's not a percent. It's a comparative scale. Meters have the ability to, as we said, account for or correct for temperature. Your meter also has the ability to set the meter for insulated or non-insulated pins, which affect the reading somewhat. Of course, you can set the meter for the species and the material, all to achieve more precise readings. Your goal is to get as precise a moisture reading as possible. The drywall gypsum scale, which was manufactured initially by Delmorst. Gypsum can be a flooring underlayment. Of course, drywall or sheetrock is your wall. Gypcrete flooring is made from gypsum. And so that's also used primarily as an underlayment. It could be used as a behind the drywall material as well. So when you have a drywall scale or a gypsum scale, it's better than just testing drywall or gypsum on a wood scale. So, because it's confusing. Drywall and wood take on moisture very differently, and I'll show you how that works. So you want to set your meter for drywall or sheetrock if you're testing drywall. And your Navigator Pro has that option. Your Pro Scan doesn't. So your Pro Scan, if you're testing drywall and you don't want to make holes in it, excuse me, you're going to use that reference scale. And you're going to have to just compare dry to wet. Establish your dry standard on the drywall if you must use the Pro Scan. So here's a great example of comparing wood readings. I'm going to just take a sip. Wood readings to drywall readings or sheetrock. So as we see here, we're going to tell you that good drywall or gypsum or sheetrock, everybody uses different words, is below 0.5%. If you're on a true drywall scale and you're testing drywall or gypsum or walls, you want to be under 0.5%, or else that's too much moisture. Look what that equates to on a wood scale. Read across, 14. Okay. So you want to be anywhere under 0.5%. 0.1 is a little too dry, but generally between 0.2 and 0.4 is perfect. 20% on a wood scale is the equivalent of 1% on a drywall scale. And in both materials, those are the thresholds for mold and decay. 20% in wood is the threshold for mold and decay in wood. 1% in drywall is the threshold for mold and decay in drywall. So you see, and you know the materials doing what you guys do. If drywall reaches 1%, you can stick your finger in it. It's too wet. It's going to create mold. 20% in wood, you may not be able to stick your finger in it really, but it's the threshold for mold in wood. So wood takes on moisture very differently than drywall, and hence the percentage of moisture content for each is different. It's like, I give the example, it's not a perfect example, but you have a 300-pound guy and a 150-pound guy, and they both drink a gallon of water. The percent moisture content in the 300-pound guy is going to be less based on his weight than the 150-pound guy that drank the same amount of water. The way they take on and give off moisture is different on these two materials. So you need to have a different scale for drywall. And because drywall is used in many, many buildings, it's very important to have that drywall scale. And you do have it on your meter. I think it's called, they may call it sheetrock. Let me just double check. Yeah, they call it a sheetrock scale. So when you have only a wood meter and you're testing drywall, it's incorrect to say percent moisture content if you're testing drywall on a wood meter or on a wood scale, because it's not a percent. The percent means the percent of moisture relative to the weight of the material. Anybody have any questions on that?
There aren't any questions on that in particular yet, although put
Okay.
it in the chat if anybody has a question on
Sure.
drywall meter measuring or moisture measuring. There are some other questions that I'm just holding to the end.
Yeah, I see it says 23 in my little Zoom bar here. for under the chat. Here's the confusion. I say confusion. This chart is from the National Institute of Health, right? We respect them. They're, a big government institution. In their moisture and mold remediation operating procedures, this was based in 2014. Okay, so it was 9 years ago. However, they're telling you in baseboard, primarily wood, 7 to 10% is good. Great. What's this? 7 to 10% in gypsum wallboard, drywall, 7 to 10%. What are they doing? They're using a wood scale and they're testing drywall, but they're calling it a percent. And what did we just say here? It is incorrect to use percent moisture content when referring to drywall readings taken on a wood scale. Why? Because if you had 7% of moisture in drywall or gypsum, it would be water on the floor. But they're incorrectly telling people what it is when using a wood meter or a wood scale testing drywall. So the confusion lies, and I get these calls all week. How does our data show that drywall or gypsum has to be under 0.5% when the National Institute of Health or some other organization, even the IICRC, the Institute for Inspection, Cleaning, and Restoration, they started all their technical research with wood meters. And so they have defaulted to a wood meter scale in testing all of these different materials. Everything's perfect. Hardwood flooring, framing, lumber, wood furnishings, baseboard, except gypsum wallboard, because you need a different scale for that. The rest of them are wood. The rest of these are wood. So that's where the confusion lies, and we answer a lot of questions here internally and when talking to our customers. So we have some new meters that you may or may not be interested in down the road. They offer some different types of readings or different types of methods for storing readings and saving them and sharing them. Our BDX 20 and BDX 30 are meters for building inspection and restoration industry. They are pin meters only at this time, although we are working on a 3-in-1 meter like your Nav Pro. So they have the display with the backlight like the Nav Pro does. They have on-screen statistics. You have wood temperature corrections, just like you do with your Nav Pro. People like these color-coded LEDs we had on some of our old meters. Green, yellow, red. So obviously red is stop, it's too high. Yellow's, middling, and green means, okay, go ahead, your moisture is good. We have on the BDX 30, we have Bluetooth connectivity, and we can talk about that a little bit. The Bluetooth connectivity on the BDX 30 gives you a choice of adding up to 37 different building material selections into the meter. Different wood species, different materials, all building materials, so that you can switch into the meter the ones you commonly test, keep the other ones in our app. And it comes with our free Delmorst Edge app, downloaded for Android or iPhone. And we have different packages with different pin electrodes available. Some of the same ones that you use with the Nav Pro. The connection's the same on the new meters. So all the old electrodes that you might have, the attachments are the same. The BDX 20 offers similar features, but no Bluetooth, and just 3 scales: a general wood scale to Douglas fir, drywall, and a relative scale. So what's nice about these is the Bluetooth feature on the BDX 30. The app, when you download the readings, looks like this. It gives you the date, the time, and actually a geotag location. Shows you the last reading you took, as well as all the other readings. A little hard to see here, but you can see all the other readings and what you set the meter for. So I set it for 70 degrees, non-insulated pins, meaning like the little pins on top of the meter, or an electrode that has non-insulated pins. You can export the readings to a file in your own phone or Dropbox file. And then you can share them, of course. Once you have anything in a file on your phone or a Dropbox, you can then email them to someone else just by filling in the email address here on the screen. And you can plot graphs to analyze your readings, check patterns, and so forth. So that's all available on the BDX30 with Bluetooth. We have a wood meter called the JX30, which has the 200 wood species. I don't know if that's as much interest to you as the BDX for building materials. The way I remember it is the BD stands for building. BDX30 is a building materials meter. The J is always our wood meters. So some other stats that it shows off: high, low, average, standard deviation. I don't remember everything from high school math, but I'm sure your engineers do, or college statistics. So it offers you all of that based on the readings that you took. You can even exclude readings that, I took a reading, that reading was no good. I want to take it out of the statistics. You can do that. You connect to the meter via the meter's serial number. See on the back. No, this one doesn't have it, but we provide a QR code on the back of the meter with a serial number, and that's how you know your phone is connected. It'll show up on your phone screen just like that. So here are the common materials that we put into the BDX30, the one with the Bluetooth. See, all of these come standard in the meter. Gyprock is Australian. That's what they call gypcrete. We sell to Australia extensively. Then you can bring in all of these other materials, take out the ones you don't like, keep the ones you do. Different wood species, as well as some engineered woods, OSB, oriented strand board, made by Avantech, 2 different types of Avantech OSB, and some other materials here, and a reference scale from one of our old meters, because people were used to it. So we kept the reference scale from an old meter, and you have the reference scale for the new meter. It's a little different. I'm not sure why they did that. There's got to be a technical reason. Gypcrete, gypsum, concrete. How do you test those? We talked about drywall and how it compares to wood, and how at 0.5%, that's the top number for drywall. Concrete and gypcrete and gypsum are a little different. Most manufacturers for concrete, if you're testing concrete, whether it's a flooring underlayment or a concrete floor in a building, a garage, for instance, or a public garage or your own garage or private garage, or a concrete flooring underlayment. Most manufacturers for concrete say that 2 to 4% moisture content is the acceptable range of moisture. You always want to check if you know the manufacturer, you can see what they say, but primarily it's 2 to 4%. And then on gypcrete or gypsum, your preparedness for gypcrete, for flooring, to put a flooring over it, is under 5%. Again, not like drywall. Drywall was under 0.5%. This is gypcrete, which needs to be under 5%. A lot better in terms of how it takes on and gives off moisture. It can handle moisture more than just drywall or sheetrock. So I can send this to you too, Ling, if you'd like to have this as well. The best way to test, you can do 2 things. You can put a slide hammer with insulated pins, which I'll show you a little bit, into the holes that you nail. The slide hammer won't take readings along the shaft of the pin, or you can drill holes that are a little wider than masonry nails and touch the pins on the meter or on an electrode attachment to the nails. You can do a surface test at 1/8 of an inch in, or a subsurface test as far as 2 or 3 inches down, depending on the thickness of the slab or of the gypcrete. Why don't you want to touch the sides of the hole? You only want to get a reading at the bottom. If you touch the sides with these masonry nails, they're not insulated, you're going to get a reading all along the shaft of that nail. So if you just want a reading at the depth, make the holes a little wider than the nail. Another benefit or useful feature for moisture meters is to test concrete via a relative humidity test. And we have probes that are approved for this ASTM 2170. Your NAVPRO has a sensor. It's not officially approved for that test. So if there's litigation involved in your subfloor test, don't use this, but it works. We have another sensor that will attach to the meter. If you need to follow this ASTM F2170, it will work with your NAVPRO. You can measure inside the slab. So there's a test that calls out for measuring 40% of the depth of the slab. We have sleeves. You put the sensor in, you detach the sensor from the meter like that. We have a cable. You put it in. It's a 24-hour test. You have to leave that in there. Leave the sleeve in there capped, and then come back and put the sensor in the sleeve. If the relative humidity reads below 75%, they say that that is a level at which you can now put a floor over the concrete. That's the readiness for concrete use in terms of relative humidity. Not moisture content, that's different. That's 2 to 4%. Not a good test if you're going under litigation. This is just for your own use, your own knowledge of moisture in the concrete. If you need to go into litigation, you need to do this test with the proper sensor, which we have for your meter, and you need to be under 75% relative humidity. So again, relative humidity, moisture content, two different measurements. Now we have a brief on all this if you're ever interested in doing this test. Another useful feature are combination meters. You've got one. You've got a 3-in-1 pin scan and thermal hygrometer. We also have a pin and scan meter without the thermal hygrometer. So you can't test the air in this other meter that we have. It's called the Tech Check Plus. It's a pin and scan only. It does not have the back portion for reading scan mode in the, excuse me, it does not have the thermal hygrometer for reading the air readings. Then we have standalone thermal hygrometers, which are only this feature. Doesn't have a connector, as you see, and it does not have a scan mode on the back. So it's just a standalone thermal hygrometer, but it does the same thing as your NAVPRO in the relative humidity mode. We will be coming out in the fall with a Bluetooth version of the standalone thermal hygrometer. And next year, we'll be coming out with a Bluetooth version of the NAVPRO at some point towards the end of next year. So here you've got the 3-in-1 modes, as we just discussed, and the standalone thermal hygrometer. They can, all the hygrometers that we have here can test to all of these scales: relative humidity, temperature, grains per pound, dew point, and air pressure. Digital pin meters. What's nice to have in a digital pin meter are all the scales, the built-in scales for the different materials, calibration checks, and a connector for an external pin electrode. Different electrodes for pin meters. You can test various materials with our electrodes, as you see here. Here's some examples of the most common electrodes used for building materials. We have a short pin electrode. It's very similar to the pins on this meter here, same size or slightly larger. There are two of them. Again, the connector connects to your NAVPRO, the connector on your Navigator Pro. Same connection for all of them. This is a behind the wall probe. These have insulated pins that only test at the tips, the depth at which you place the tips behind the wall. So if you drill pilot holes or use a tool that we have to make pilot holes, you can then push this into the drywall and test the insulation behind the drywall, or you can test even wall joists, wall joists behind the drywall. Everybody likes to pick this one up when we're at trade shows. It's a blade electrode. And what you do is you slide these bent blades behind the baseboard. And again, insulated shafts only test at the uninsulated tips. So you can go down as deep as you'd like, as far as the electrode will let you, and test behind the baseboard for moisture. And our most popular electrode is the 26ES slide hammer, which can test hardwoods. Again, insulated pins, only testing at the depth at which you place the tips.
Ilene, there's a question about that. How deep do you know how the depth of the pin. How do you know the depth of the pin? Like if you're hammering in.
So a couple of things we can do. Number one, you can just guess, you touch the pins to the surface, punch it in 1/8 of an inch, a little bit. You just give it a couple of bangs on the head with this slide and take a reading. And then you can go a little further, hammer it in, hammer it in. The standard pins on these are 2 inches long. They penetrate 1.25 inches max. And I'm gonna get to your specific question in a moment. These also are available with shorter or longer pins with different attachments to the head. The shorter pins go on here on the standard one. A different head attachment can provide you with up to 6-inch penetration. Now, on this particular slide hammer, we have what's called the 26 ED. And the D stands for depth. It has a depth gauge that we can provide on the slide hammer to show you how deep you're going. It's a separate part number, but we can build it into the slide hammer, and it's called the 26 ED, and it shows you how deep you're going into the material. Does that answer your question, Lily?
Yeah, that was great. Thanks.
Okay. So again, the new meters for water damage restoration include the BDX meters with and without Bluetooth, the 2-in-1 meter, pin and pinless. Again, here's an example of that behind the wall probe. We make all of our meters are available in various packages with either one electrode, or in this case, you see here 3 different electrodes, the short pin, the behind the wall, and the slide hammer right there. Okay. And this one has the thermal hygrometer sensor. The QuickNav is an interesting meter. It's very similar to your NavPro. By the way, now we make the NavPro in yellow as well. During COVID, it was hard to get the blue for some reason, with supply chain issues. So everything's in yellow now. Sorry. The QuickNav has the same basic functions. It's a 3-in-1 meter, just like your NavPro, only it has no storage and download functions, and the wood scale is only to Doug fir. Has a wood scale to Doug fir, a drywall scale, and a relative scale. It has a scan mode, the same as the NavPro, and it has that pin attachment availability for the electrodes, and it comes with the same sensor that you have on your NavPro. So it's a little less money than the NavPro. If you don't use the storage and download functions and you don't care about having specific, maybe a half a dozen wood species, and some other specific settings for materials, the QuickNav will be the way to go in terms of cost savings. People take a picture of the screen because they don't store the readings. The readings don't store on the QuickNav. The standalone thermal hygrometer we talked about, the new version coming soon. We also have paper meters. Now, why would you guys be interested in paper meters? I don't know if you get involved in this, Ling, but not so much recycling, but office files, book restorations in libraries, bookstores, etc., that suffer damage. Also, cellulose insulation in, I think primarily modular homes use cellulose insulation. Maybe you guys know better than I. But cellulose insulation is paper-based. And so we have a couple of makers of homes, the home builders, home builder companies that use our paper meter to test the cellulose insulation. So our paper meter looks like this now. We have a new one, again, with the option for Bluetooth and downloading the readings and sharing, that is calibrated for only paper. We have you can use it for corrugated, you can use it for recycling, you can use it for craft stock, or it has a relative scale.
Actually, the cellulose is really relevant to our building stock here. Could the NavPro be used with cellulose if you use the relative scale, or if you had a way to?
Well, sure. You can put the pin mode on the NavPro onto the relative scale. You won't get a real percent because it's not a paper scale. So it'll be a comparative reading. People use those words interchangeably: relative, reference, comparative, same thing. You're comparing dry versus wet. So if you were to use the NavPro in the pin mode with a pin electrode attachment in the cellulose insulation, and I suggest that 21E with the longer behind the wall pins, similar to when we test fiberglass insulation. On the NAPRO, you'd have to use the relative scale, take a reading on dry cellulose insulation, obtain that dry standard on the 0 to 100 scale, say it's 20, let's just say 20 is dry on your dry cellulose insulation, then go test areas of concern. If it's significantly higher than 20, obviously you have to dry it down to 20. 20 is your number, the dry standard. Otherwise, you can call me and place an order for a paper meter. And you get this one or one of our older ones. You can use the 20 with all the same scales, or the 30 with the ability to store and download the readings. The 20 versions of all of our meters, the BDX building one or the paper one, they're about $100 less than the 30 version. The 30 version always is the one with the Bluetooth. And they come in different packages with different electrodes as well, or availability of electrodes. Towards the end now, useful features, you want to make sure you calibrate it, you're checking the calibration on your meter. We get meters in here all the time. Rose here can attest to that. People want their meters recalibrated. They want a certificate of recalibration or calibration. We do all that. If it's in warranty, we will provide the recalibration within the warranty period at no charge. The certificate is a small fee. If it's beyond the warranty period, the repairs are generally about $125, depending on what's wrong with the meter. It could be more if there are parts and labor required. You have a couple of different ways of checking the calibration on the meter. You guys on the NAPRO, you do not have an internal calibration check. So what do? You're going to use this in the wood mode, setting the meter for the wood scale on the pin mode, and you're going to touch the pin electrode attachment to either, and this is the same. I'm just showing you the front and the back. This is our MCS1 calibration block. You're going to touch the pins to the center contact, and on one side, either the 12% test and check the meter that way, or on the higher moisture content, it tests it both ways. On the 22% side, on this side, you would check the calibration on that side as well. And if it's beyond plus or minus 0.2 on each of those, then you want to call us and see what we need to do. Your ProScan also has a calibration block. It's a pinless meter calibration block. It's called an SCB1, and that's available as well to check the calibration on the meter. However, not always necessary unless you're very, very concerned about the meter, because the ProScan has, as we saw before, as I demonstrated, it has an internal calibration check. So you can just check the calibration with the press of a couple of buttons on your ProScan. Our new meters have an internal calibration check as well, up to it's to testing to 12%. So you can do it internally with some of our meters, with the NAPRO and some of these shape meters, like your NAPRO being the same shape. We use the calibration block here, these two, this one. This is available, Ling, by the way. We have them here at Delmorst. They're $45 currently to test your NAPRO.
Yeah,
I say
sounds like we
NAPRO.
should get one of those.
Yeah. I say NAPRO, Navigator Pro, it's the same thing. It's the short name. How do you test your sensor? I showed you how to test the wood scale. How do you test your sensor? So there's a couple of ways. You can keep an extra sensor on hand and check one against the other. Of course, they come off, so you can put the other one on, make sure you're getting similar readings in the air. Or we sell a calibration salt test solution kit, and you would just put the sensor in there, leave it overnight, 12-hour minimum, come back the next day. Always want to do this before you start your job. Know the night before you're going to start a job and you need the sensor. I would say do this, or check it against the other sensor. In your case, you're not primarily doing flooring, so you're going to get the 33% bottle, and there are instructions and a little chart on the bottle as to how to test the sensor in the salt solution kit. A little bit of care for the sensor and the meters. Don't leave your meter in a hot car outside the case. And always, and again, any meter, whether it's just a pin meter, a pinless meter, or the NAPRO that has everything take off the sensor, put the sensor in the bag that we provide. There should be in all the NAPRO kits a little silver Ziploc bag. We provide it when we first sell the meter, that comes with it. You want to keep the sensor in the bag when you're not using it. And it protects against humidity and moisture so that it helps the sensor last longer. There's a reason why the meter is warranted for a year. The new meters are warranted for 2 years, by the way, but the sensor is only warranted for 90 days. So you want to keep that in the bag in an HVAC controlled environment when you go home after your job.
So Eileen, I just want to be clear about that.
Yes.
You're talking about an extra sensor that you would have for calibration, or you mean the sensor should always be removed from the meter and stored this way when it's not in use?
Yes and yes. So your meter, when you buy a NAPRO, you get the sensor with it. And depending on which kit, you get different electrode attachments with a pin. You get one sensor. You can purchase an extra sensor. We sell these separately, the same sensor, same one. You know, we sell them separately, and we ship them in those silver bags. And you got a silver bag in the kit when you bought the meter as well. So whatever sensors you own, when they're not in use, keep them in an ambient temperature environment, not hot, not cold, just, 70 degrees, between 50 and 90, 50 and 80, but keep them in this bag, but also keep the meter in the carrying case, not in hot, not in cold environments. Don't leave it in the car overnight when it's 90 degrees outside or worse, or in the winter, same thing. Keep the meters in a controlled environment when you're not traveling around with them. Does that answer the question?
Yep, thank you.
Okay, sure. And then finally, know your moisture meter, read the manual, call us if you have questions. Keep in mind that different brands of meters, and I understand you only use ours, but different brands of meters might read differently. So you want to use the same meter on a job to get consistent readings, to obtain consistent readings on the scales that are built into the meter. Make sure your meter's in calibration before you start. Your batteries are good to go. Always an alkaline battery. By the way, the new meters take 2 AA's, easier to find. The old ones take the 9-volt, but all alkaline. Don't buy lithium. Don't buy low energy, some other kinds, just alkaline. Check that your pins are, look good, and the insulation hasn't worn off if they're insulated. Follow our procedures for the meter. Follow the procedures of the manufacturing recommendations of the material if you have them. Understanding that only builders have them, and installers, inspectors, and people testing existing structures don't always have that manufacturer information on the particular material. Understand that. So you go to your default settings. You, the user, make sure you're putting in the proper settings with the knowledge that you have. Drive the pins to the proper depth. Make sure surface moisture is not affecting your pinless meter. If so, use a pin meter. Know what the meter can do, and you're all you can all apply your knowledge and experience because you've done this. Okay, I am finished, Ling. If anybody has questions, I'm free to answer them now. There's my phone number on the bottom there and my email address. If anyone else would like to send me some questions or comments or anything else, good, bad, and ugly.
Thank you, Eileen. There is one more question from the chat. Somebody was asking about, so you said it's best to align the pins with the grain. Right. And there's a question about using the pins in end grain.
Good question. So we always recommend, let's just say you had a piece of lumber. We always recommend testing into the face of the board parallel to the grain for the most accurate readings. However, we sell extensively to the lumber mill, sawmill, and dry kiln industry. and they ask the same question. Many times the end grain, the ends of the board will dry quicker than the center. And so they want to see how that piece or board is drying. So we do say that, yes, you can push the pins or the slide hammer pins or the pins on the meter into the end grain and take a reading, just to give you an idea of how moisture is drying from the ends versus the face, the center of the board. So that's fine to do as well. Just as a note, there are some European meter manufacturers, not many, and some of those, their meters are programmed for you to test perpendicular to the grain at right angles, but not ours. Ours are programmed so that you test parallel to the grain.
Okay, thank you. There's a question, do older meters simply stop working accurately? So if somebody's had a meter for a while, they've sort of been neglecting it, 5 years later, they want to open it up. Is that one gonna be working still?
So I'm glad you asked that, because you reminded me of something else, and then I'll answer that. When you're not using the meter for more than a few weeks, always take the battery out. Just throw it in the case. If you haven't used it in months, get a fresh battery, because those degrade on the shelf over time. You buy a battery, even you buy a new battery at Home Depot or wherever, you don't know how long they're sitting on the shelf. Worse at a drugstore, because they could sit there forever. People don't go to a drugstore to buy batteries generally. They'll go to a hardware store or the supermarket. In terms of older meters, we service older meters, even the ones that we no longer manufacture. If the battery's kept in the meter, it degrades. Obviously, you have corrosion like any kid's toy or a flashlight, but it also degrades the PC board components, because there is electrical leakage from the battery to the PC board components. So they do degrade. So if the battery is removed, you're better off when you're not using it for more than a few weeks. In terms of the older meters, we don't always have parts to service it. Now, if you take out the meter and check the calibration and it looks okay, you put in a fresh battery, it seems to be working. A lot of times I'll test people on the phone. I'll test myself. I'll set the meter to the wood scale and I'll take a reading on myself. And I know that humans are between 15 and 25. Here I'm 17 and a half on the wood scale. Okay. I'm beyond what the meter is set for, but I can tell if a meter works remotely over the phone in most cases. If it's something that we recently discontinued, most likely we can repair it if it's not working. If it's something, people call me, we have a meter called the BD10. Somebody calls me with a BD5 that was, a generation ago. We don't have the parts to repair those any longer. But again, checking the calibration, checking it on yourself, testing it on some material in your home or nearby where you're sitting. Those can help determine whether the meter actually works or not. But the best thing to do is keep the battery out, and it'll keep the meter working longer.
Thank you. I just removed the battery from the meter that's sitting on my desk right here. Thanks for saying that.
Great.
So I think that's the end of the questions that are in the chat. Would anybody like to be unmuted? You can raise your hand with the controls at the bottom of your Zoom screen, or last chance at questions in the chat. And I'll just say, Ilene, while we're waiting for any last questions to dribble in, this was fantastic. Thank you so much for sharing your expertise. I really appreciate the overall view of how moisture meters work, in addition to the tour of the moisture meters that Delmorst has currently. And we've really gotten some tips about maintaining our own moisture meters. And I have ideas about how to make our lending program more robust. So I really appreciate your time today.
My pleasure, Ling and Bryn as well. Thank you for moderating. And again, my contact information is down at the bottom of the screen. And you can contact me. Those letters after my name just mean my boss made me take some IICRC courses that I passed. So it helps us talk to folks such as yourselves or water restoration technicians. We went through a hands-on class. The IICRC offers certification in certain categories, about a dozen categories. The two that were that I took were water restoration technician and applied structural drying. Those are the initials there. So that I kind of know what technicians do on the job and how they can best use our meters. So I don't actually do the work. I sit at a desk, travel once in a while to a trade show.
Well, the
Um,
work you do is very important, so thank you so much, Eileen. There's a short survey after you log off, so if you wouldn't mind taking a few minutes to give us a little bit of feedback, we'd appreciate that. And then
Sure.
Eileen, if you wouldn't mind sharing your slides with Ling and I, we'll include that in a follow-up email to attendees.
Great. And thank you everyone for your time and appreciate you coming today.
Thanks so much. Have a great day and a great
Too.
weekend.
You too. Bye-bye.
Bye-bye.
Bye, Eileen. Thank you. Bye, everybody.